Chapter 6, Section 10 is going to cover the topics of functions and their graphs. So there's a couple words you need to know here. First is a relation. A relation is a set of any ordered pairs. It's any way that you want to group items. You can group it as an ordered pair, you can group it on a graph, you can group it on a table. Anything that's grouped is a relation. Now a function is a special type of relation. And in a function, every value of the input or the independent variable corresponds to a unique value of the dependent variable. So every x should correspond to only one y. The set of x's that you use, or the independent variable, is going to be called the domain. And the outputs, the y values that come out after you input the x value, is going to be called the range. On a graph, you'll describe the domain from left to right, and you'll describe the range from the bottom of the picture to the top. This is an example of function, domain, and range. A function is essentially going to look like an equation, which will have the dependent variable and the independent variable. The dependent variable and the independent variable. The independent variable will be substituted in for the in, and then the answer that comes out will make the range. So for example, if I took 0 times 129, I would get 0. 1 times 129 would give me 129. And notice that these are forming ordered pairs. The x forms the domain, the y forms the range. Vertical line test is a way you can tell if you have a function or not. If a vertical line can be drawn so that it intersects the graph at more than one spot, then the x does not have one unique value of y, and so then the graph is not a function. So for example, let's say I looked at the graph of a circle. If I did the vertical line test of this graph, the vertical line would intersect in more than one spot. That's bad. That means it is not a function. But if you looked at the graph of a parabola, oops, not that one, a parabola, and you drew a vertical line, and you can draw the vertical line anywhere, notice that the vertical line only intersects at one spot and one spot only. So that is good. That means this is a function. Linear functions. The graph of any linear equation of the form of y equals ax plus b, we called it y equals mx plus b earlier, will pass the vertical line test no matter what. So that means the equation of any line in the form of y equals ax plus b gets to be called a function. In order to show that something's a function, often instead of using y, they'll switch it out with an f of x. The f of x and the y mean the exact same thing, so if you don't like the way the f of x looks, you can take it out and put the y back in. The graphs of linear functions are straight lines. They are always going to pass the vertical line test. You can graph the linear functions by plotting points, by using intercepts, or by using the slope and the y-intercept. So for example, if I gave you the linear function f of x equals 2x minus 1, and I asked you to graph it, you could go to your y-axis and plot your y-intercept at -1, and then you can use your rise over run to go up to right 1 to get another dot, and you have graphed the function. So it's just like we did before. Don't let the f of x notation throw you off. The standard form of a quadratic equation is y equals ax squared plus bx plus c. Graphs of quadratic equations are always going to pass the vertical line test and will be functions. To denote that they are functions, notice that they are going to switch the y to the f of x again. So again, same notation as before, it's just to show that it's a function. The graph of every quadratic is going to form a parabola. A parabola is a U shape. It can either open up or it can open down. A parabola is going to open up when the coefficient a is greater than 0. I always tell people it opens up like a cup. The parabola is going to open down when the a coefficient is negative, and I always tell people down like a frown. When you graph a quadratic equation, often you'll be asked to find the vertex. The vertex is either the minimum or the maximum, depending on if it opens up or down. And you'll also be asked about the axis of symmetry. Notice the axis of symmetry goes through the vertex. It is a vertical line, so it'll be written in the form of x equals a number. And the axis of symmetry is where the parabola is cut in half. The left-hand side of the parabola and the right-hand side of the parabola should always look the same. So again, the vertex of a parabola is the lowest point if it opens up. It is the highest point if it opens down. Every parabola is symmetric with respect to the vertical line through its axis, and this is called the axis of symmetry. In order to find the axis of symmetry, there's a formula that you can use. Remember, x equals a number is a vertical line, and the way you find the number of the vertical line is you take negative b divided by 2a. This is also going to be the x-coordinate of your vertex. Now keep in mind a vertex is a point, so this will be the x value of the point. In order to find the y value of the point, you will need to substitute this answer into the equation in order to figure out the corresponding y value. So when you are asked to graph a quadratic equation, first thing I recommend that you do is decide if it's going to open up or down, find your axis of symmetry, find your vertex, find your y-intercepts. You do that by substituting x equals 0 into the equation. Find your x-intercept, if they have them, sometimes it doesn't have them. Do that by substituting y into the equation, and then draw the graph using all of the things that you've found previously. So let's look at an example. Let's say that I asked you to sketch the graph of x squared minus 6x plus 8. And then after you sketch the graph, I want you to locate the domain and the range. Okay, so first thing I would do is I would decide if it's going to open up or down. This is going to open up because the a value is a positive 1, so this will open up like a cup. Next thing you want to do is you want to find your axis of symmetry. So the axis of symmetry is found by taking negative b divided by 2a. The b value in this problem is negative 6, and the a value is 1. Negative 6 makes a positive 6, and 2 times 1 is a 2. 6 divided by 2 is 3. So your axis of symmetry is going to be the vertical line x equals 3. So everything that happens on the right side of that line will also happen on the left side of that line. Next, we're going to find our vertex. We already know that the x value of the vertex is 3, but in order to find the y value of the vertex, we need to take the 3 and substitute it into the equation to see what y value corresponds with x equals 3. So if you do that, that would give you 9 minus 18 plus 8. Well, 9 minus 18 is negative 9, and negative 9 plus 8 is negative 1. So our vertex will be happening at 3, negative 1. And so then we can plot that dot. So because our parabola opens up, this is going to end up being the minimum of your parabola. Next, now that we have our axis of symmetry and our vertex, now we need to find our y-intercept. You find the y-intercept by substituting 0 in for all of the x's. The y-intercept will occur at 8. So on your y-axis, you can plot a dot at 8. Now what's kind of cool is that is 3 spaces to the left of the parabola, of the axis of symmetry. So you could also go 3 spaces to the right of the axis of symmetry, and you'll have another line located at 6, 8. In addition, you then need to find your x-intercepts if you have any. The way you find your x-intercepts is by setting the equation equal to 0, or setting y equal to 0. And then you have to solve the quadratic using one of the techniques we learned in the last section. So if it's factorable, you should factor it. If it does not factor, use the quadratic formula. This one does factor. Things that multiply to be 8 and add to be -6 are -2 and -4. If I use the zero product property, my two x-intercepts should happen at 2 and at 4. So I can put a dot at 2 and a dot at 4. Once you have all of that, you have enough information to sketch your graph. Now, I personally always like to check my answer on my calculator. So let me show you how to do that really quick. So on my calculator, first thing I'm going to do is turn the calculator on. Then I'm going to hit the button that says y equals. I'm going to clear some stuff out that I have in there. And then I'm going to type in the equation. My equation was x squared, so this is your x button, x comma t comma theta, x squared, and then I have minus 6x plus 8. I'm going to hit the button in the corner that says graph, and it's going to generate the parabola for me. Now, if the picture's not good enough and you need to see the exact points, you can see the exact points by hitting second and graph again, and it will tell you all the points that are on your graph. So notice we have the point 2, 0, that's our x-intercept. We have the point 0, 8, that's our y-intercept. We have the point 3, -1, that's our vertex. 4, 0 is our other x-intercept. And then remember I said we were going to go through 6, 8. So that's a good way for you to check your answer. And I recommend doing that on these graphing problems. Next topic will be exponential functions. Many real-life problems, including population growth, growth of bacteria, and decay of radioactive substances, increase or decrease at a very rapid rate, and that rate is called exponentially. The equation of a graph that increases or decreases exponentially is called an exponential equation or an exponential function. Exponential functions look like, or equations look like y equals a to the x. Notice the x is the exponent. Or you can switch it to function notation, which is f of x equals a to the x. The graph of an exponential equation or an exponential function is going to have this sloped appearance. It typically does not touch the x-axis unless it's been shifted. When dealing with exponential growth or decay in story problems, the formula P of t equals P naught a to the kt is your exponential growth or decay function. The P sub 0 represents the original amount that was present. The P of t represents the amount that's present after t years. A is a constant and k is a growth constant. If both the k is positive and the a is bigger than 1, you will have an exponential growth. If the k is less than 0 and the a is bigger than 1, you will have exponential decay. When the a in the exponential function is replaced with the letter e, we have what's called the natural exponential function, and it looks like f of x equals e to the x. The population growth equation will change, and the only thing that changes is that the a gets swapped for the e. So P of t equals P naught e to the kt. The letter e is an irrational number. It's called the natural number. It is approximately 2.7183. Your calculator is programmed with this letter e. It's just like pi is 3.14, and your calculator is programmed with that. So whenever doing math with the letter e, please use the button on your calculator. So for an example, we can check out a story problem that involves exponentials. Plutonium is a radioactive material used in most nuclear reactors, and it decays exponentially at a rate of 0.003% per year. If there was originally 2,000 grams of plutonium, the amount of plutonium remaining after t years is P of t equals 2,000 e to the negative 0.00003 t. How many plutonium will remain after 50 years? So a few things I want you to notice. First, this was a decay problem. Notice that the exponent was negative. That's always going to happen. Also, they gave you the decay rate as a percentage. Notice we took it out of percentage form by moving the decimal place 2 places to the left. Also, they told us how much we started with. Notice that that is the coefficient in front of the E. The question is, how much plutonium will be there after 50 years? You need to substitute the 50 in for the T. So we will take 2,000 E to the negative 0.00003 times 50. Now, honestly, the best way to go about doing these problems is to do it with your calculator, because raising 2 to 2.7 to a power in your head is no fun. Okay, so let's do this on our calculator. So I'm going to go to my calculator screen. I'm going to get out of where I was previously by hitting second and quit. And then I'm going to type in my 2,000. My E button is on the left. It's above where it says LN. Notice it says E to the X there. So I'm going to have to hit second LN to get to my E to the X. And then my calculator's updated, so it's already putting me in the exponent spot. If not, you'll need to use parentheses. So I'll put my negative 0.00003 times 50. And then I can hit enter. There's 1,997.00 grams left in 50 years. Okay, last expectation is that you will graph these equations. So I graph them just like anything else. I like to, I like to make t-tables when I graph. So I pick a couple x values, and again, I don't go crazy. I usually pick 0, 1, and 2, -1, and -2. And I use my calculator to help me figure it out. So for example, I can take 2 to the second power, and that's going to give me 4. I can take 2 to the first power, and that's going to give me 2. A lot of people get 2 to the 0 power wrong. They think it's 0. It's actually 1. If you don't believe me, try it on your calculator. 2 to the -1 is not going to form a negative number. It's going to form a fraction of 1/2, or 0.5 if you prefer decimals. And 2 to the -2 is going to form 1/4, or 0.25 if you like decimals. So if I go to graph this, I will have dots 1, 2, 3, 4. At 2, 4, 1, 2, 0, 1, -1, 1/2, -2, 1/4. So your graph ends up looking like this exponential growth. And then they ask you for the domain. The domain is talking about the x's. So they want to know how far to the left and how far to the right my graph goes. Well, theoretically, it's going to go left and right forever. So my domain in this problem, I would say, is all real numbers. Okay. My range is talking about the y's, and they want to know how far down I go. Well, if I keep going, -3, -4, -5, it's just going to get closer and closer to the x-axis, but it's never actually going to touch the x-axis. So the lowest I get is almost 0. And then the highest I get, well, it's going to keep growing forever. So my range is all y values that are larger than 0. If you go to graph y equals 1/2 x, you're going to get exponential decay. So if I make my t-table and I pick 0, 1, 2, if I substitute that in, 1/2 to the 0 is going to be 1. 1/2 to the 1 is 1/2. And 1/2 squared will be 1/4. Then if I try -1 and -2, it's then going to end up giving me the reciprocal. So 1/2 to the -1 will be 2, and 1/2 to the -2 will be 4. So if I go to graph this, it's going to look like the mirror image of what I just graphed. So you'll end up starting high and finishing low. And because you finish low, that's why they call it decay. Notice the domain and the range are the same. The domain, from left to right, I went left forever and right forever, so it's still all real numbers. And the range still only used positive numbers, so y is bigger than 0.